Hi there, I'm Carrie Ellis, author of 21st Century Superhuman. This is our 21st Century Superhuman show. Today I have with me Dave Stewart from Peru. Hey Dave, how are you doing?
Hey, hi. Hi from Keshe Foundation, Peru.
Yeah, and Jackie out in California.
Hi.
And who's been measuring field strengths of GANSs and plasma waters and all kinds of things. And our beloved JC from Canada.
Hi, everybody.
So good to be here with you all today, and let's onward and forward. What we got to talk about?
Take it away, Dave.
Okay, you want me to start, Dave? Okay, go.
Whoever wants to start, go for it.
Sorry, I muted myself, and so, well, I've got a few things that we need to talk about, and maybe even include a small discussion on stuff, but I think behind me says it all. That's the new GANS room there. And this is what we want to talk about, is because we've got hydrogen GANS, tritium GANS, deuterium GANS,
wow.
and having conversations with Keshe people at the top, we're going to be getting lift from these GANS, and I think that's what's important. Now, I'll give you an idea that the old, should we say, Jackie, the old Keshe Peru unit, the Magrav car, I think this is secondary now, because what we're going to do is we can open this up and we can change, like Jackie does in California, we can change some of the mechanics of how we make these and put them together so that we've got less glue. But John Bliven tells us, you put those 3 GANs in here and the car just tests the weight of the car. We do believe it's going to be nearly weightless, and that's what we're moving to now. So I think the most important discussion has got to be how to make hydrogen, tritium, deuterium GANs, and they're not that difficult once you get a principle in your mind set how to make them. So I'll walk you through that. But Jackie's just been to see John Bliven, so she might have something more than I've got here in Peru. So what are you going to tell us, Jackie? Anything?
And again, we were saying, Dave, you turned away when you said it, but again, those 3 GANSs are hydrogen, tritium, and deuterium, correct? And those are, they are very potent elements, but these are the GANSs of those elements. So a very exciting process we've been in the last several weeks with the Keshe Foundation learning to make these things.
Now, I want to just emphasize a point here, because there don't anyone running off and saying, hey, you guys, tritium is radioactive. We're making the non-radioactive one.
Correct.
It's very vital to know that
yes.
we're not making anything dangerous here. So, yeah.
Correct.
Now, another thing that I know, and now Jackie might be even more advanced than me, or even John might be, I don't know, but you've got a sequence of, should we say, 1, 2, 3 of those 3 GANs, and you put deuterium at the top, tritium, and then hydrogen. They've got to go in that order because there is a reaction going on in the energy fields. You know, if I was to show you the energy fields, which is that picture there, there's 3 energy fields going on in there, and it's vital. Let me show you a bit closer.
And what is that order again, Dave, from top to bottom?
Now look, I could be making a mistake here, but I do believe, if I remember right, and I might have even written it down, but it's deuterium, tritium, and hydrogen. So there you go, back again.
Perfect. Jackie, tell us your take on these things.
Yes, that's definitely the next step that we need to do. I spoke to John Bliven yesterday, and he showed me all the processes going on, so that was exciting. And that's going to be the next step. So, but what I've been playing with was actually something a little different. And John was interested in what I was doing, so I wanted to share the next stage of these GANSs. So I don't know if you remember, but we plasmatized everything coming into the house.
Yeah.
So what we did is
Tell us what that means, because I love that you did that. It's such a simple idea. Anyone could do this.
anybody could do this.
Yes.
So we have a 7-stage filter system in our house. We actually took one of the cartridge, it's a drop-down filter, the cartridge from the drop-down filter. We emptied it all out. It was a carbon one. Did you turn that off?
Yeah.
Yeah, so it's a carbon one. Can you hear me better?
Yeah, just talk in a normal voice.
So it dropped down, we got rid of all of that, and then we filled it with a tube of CO2 GANS.
Oh, so you have the CO2 GANS in a tube inside the filter.
Yes.
3/4-inch pipe with caps.
Yeah, and a 3/4, and it was a plastic pipe.
Yeah, plastic
Just
pipe.
a regular plastic pipe with caps. So as the water gets filtered through our system, and we put it into the 7th filter, into the very last filtering system. So, you know, that's at one stage, but we have it at another stage, which is the one I wanted to explain it, which is right at the front of the house. We did this.
Water comes into the property.
Yeah, where the water comes into the property, and it's the cartridge. We use the same thing, the cartridge, and we set it up down there. But what we did is we took this kind of tubing, we filled that with CO2 GANS, and we wrapped it around a pipe.
1-inch copper pipe.
And so when you did the CO2 GANS in there, you used the actual colored part of the GANS itself. Is that correct?
A mix. So it would be the water on top, roughly about 50-50. Just shake it up and put that into the PVC tubing, wrap that around the pipe. And then we connected it to the house. So what size is our house piping?
1 inch.
It's 1 inch. So actually it creates a reduction as well, because what we wanted to do was kind of create a vortex. So Ken actually put in some copper spiral, so that it just helps to create that vortex as it goes through. So
he put that inside the tubing?
Yeah, we put it, well, okay, because it's a 1-inch pipe with a reducer, because our actual house pipes are.
No, it's 1 inch.
Oh, those are all 1 inch? I thought we
Yeah.
reduced it down there.
Did not. I ran 1 inch.
We ran, and all of our house pipes are 1 inch?
Yes.
Okay, so it's 1 inch. Yeah, he just actually welded it into there, soldered it in. So he uses some solder and just put it in there. So it creates a little vortex as it comes through. So that's where it begins. Then it comes through our filtering system. And when I started to look at the field, so as you know, I douse. So a regular cup of water that would, you know, just come out of the tap normally has a plasma field of about 3 feet. It's, you know, it's not very large at all, nothing to write home about. After we plasmatized the water coming in, the field rose to about 15 feet. So we have a distiller here. I don't know if you can see our distiller. I distill my own water when I make GANS. So what I discovered was when you distill the plasmatized water, it does not affect the plasma field. It stays at 15 feet post distillation. So that was kind of an exciting find. So that changed the GANS that I was making. Now I was making a much stronger GANS, or I was starting from a stronger point. So I created GANS from that, and what I noticed is the fields of the GANS also increased. They went from approximately 85 feet for CO2 up to, it probably trebled in size. It got to be like about 200 feet. So, or 245 feet, thereabouts. So we saw that treble. So then what I did is I took.
So is this you measuring out in the street at your house? I'm just picturing you because I've been there.
Yeah. This has got pretty extreme, believe you me. So with that GANS, and this would be number 1 here. So I took CUO, which has a much bigger field anyway, and I numbered them 1 because these were the first ones that I made with plasmatized water. So these had a much stronger field than regular GANS. I have measured John Bliven's. My regular GANS is exactly the same strength as John Bliven's, within a foot or 2. I mean, there's really hardly any difference between our GANS.
Wow. Jackie, before you go on this direction, what do you think would happen if somebody put the plasma water, the GANS, in tubing on the water feed coming into their house without a filter. Say somebody doesn't have a filter, but they have regular city water. Any ideas of what would happen?
Yeah, that's, we tested that. It's not going to change the ppms, let's say. It's not going to, the parts per million, your TDS test won't change. Nothing else will change. Let's come back to this question at the end, because we've come up with various ways that people could actually do this themselves at home, which are really simple little things.
Great, cool.
So, yeah. So what we did after we made our first lot of GANS, this would be the first, what I'm going to call a super GANS. So it's the first stage GANS. Ken came up with this nice little design. We call this one number 1. It was made from the first stage of our super GANS. So this here is a little plasma water device. Inside here, we have a little piece of this tubing in a circle, and it contains CuO and CO2 GANS. So literally, you can just hook this up to your garden hose, or your hose bib at one end, your hose at the other end, and this will create a plasma field. Actually had super GANS. So the field that I read from the water from here, remember we went from like 3 feet to 15 feet. This went up to now 45 feet. So just the water out of here went up to 45 feet. So it's about treble. Actually, this one might have actually been bigger, but it's about treble is what we look like, about 3 times the size each time. So then what I did is I distilled that water. So you kind of get the pattern here. So I distilled that water, did not affect the field, and I made a super GANS. Now that field got to be pretty large. So for instance, now don't laugh, yes, I was dousing 1.5 miles.
So when you say you made a super GANS, then you use the water that came through that device you just showed us as the base for your GANS again, correct?
Yes, yes.
Okay.
For my GANS, yes, and that in itself creates a field with a GANS, and it's the same type of GANS. You're able to you're able to test it as CO2 plasma field, so it will show you how big the CO2 plasma field is. And so with CuO, we went from like 95 feet, to like 200 and something feet, up to 1.5 miles. So. And we just did our third stage, our super GANS.
Wow.
And we did actually get some pretty amazing results from that. So now, okay, so now I'm not walking down the street looking like a crazy lady. Now we've been moving in a car, and I've actually, we can blame a lady called Pamela here that came to one of my workshops and brought me these, gave me these dowsing rods. But now I'm elevated to pendulums. They're a lot easier to use. And I've just tested them on my first super GANS. As you can see, I talk a lot faster, run a lot faster. No, I'm kidding. But so this is at my second stage, and my CuO is now 5.2 miles. So I first tested it with my pendulum, and I was really surprised. I was expecting it to be around 4.5 miles, and when it tested at like 5 point, well, with the pendulum, I looked at between 5 and 6 miles. Those are the only questions I asked. I didn't get very specific. And then I hopped in a car and we went for a ride, and the car measured it at 5.2 miles. So, my ambition was to reach as high as the chemtrails, which apparently, according to you guys, I've now reached.
That is awesome, Jackie. And you really weren't a big dowser or anything when you started doing this.
No, not at all. I'm a healthy skeptic. So I do tests every now and again. It was kind of nice to confirm I want to get a little bit more specific with the pendulum, but it was really nice to see, how far that went, and I was able to confirm it with my rods, which I love. But walking around with rods is not very convenient, and it does look a little crazy. But yeah, so now if we start to do this with hydrogen, like John said, this is kind of an eye-opening thing. And also he said, if I listen to 6 and 8, section 6 and 8 of the peace workshop, the workshop that some of the stuff that Mr. Keshe just released, he said it kind of goes hand in hand with what he's saying, that you take the strength of one and build on the next one. So, in my own little crazy world, I had already been doing that. And John thought that was very interesting. So now in terms of what we've discovered with this, so, I kind of got to this theory that, okay, so I could just take my glass jar and just sit that inside my container to plasmatize that water. That didn't work as well. It seems to work. I just found that the glass was not very good for permeating those fields out to the GANS. Plastic is by far better. For people who are at home and they want a really simple thing that they can do, if you cut, a few inches, like go look in your shower, see how long the neck is on your shower. And Dave Paris came up with this idea. We had to make him one the other day. So you can just fill one of these with GANS. We found these little caps that kind of work pretty well. There are some other ones that we have here somewhere, but these will hold the GANS in there. And
aren't those caps from like the sprinkling, lawn sprinkling? I think is a good place to find those sort of.
Yes, sprinkler systems.
Yeah.
So you want this is just a 1/4 inch tubing, and so you can cut it, put the little sprinkler caps on the end. Make sure they're not the ones with the holes in it, because these ones actually are the ones that we use to go all the way round. There are some other ones that we have that are plugs. I had them a little earlier.
Yeah, and I will say, having traveled a lot, I mean, you just have to go hunt for what's available in your country, in your location, at your supply stores that have to do with hardware or various things. JC, would you have any other suggestions on plugging these tubes?
Epoxy, hot glue, try to avoid silicone. We've seemed to have a number of issues with silicone. Another option would be to, if you have a mandrel, something you can stick in the end of that tube, you heat the end of the tube up, stretch it open, and then just put it on the other side, because that vinyl tubing, when it cools off, it shrinks, and you will get a very strong connection that way. You
could even do that with a carved piece of wood if you had to, I would think.
Well, wood's going to leak.
Yeah.
I mean, you can, if you have a small piece of plastic, you could drill a hole in it, just big enough so the tube slides in, put a little bit of super glue on the edges, and squish it together.
Brilliant. Okay, so yeah, there's so many simple ways to do this, and people ask, and they want to make it complex, but it's like we just have to look for solutions. We have Dave, go ahead.
Just while Dave is digging, you can usually get tubing in like a range of sizes, so that you can get one that the inside diameter is the same as the outside diameter of your smaller tubing. And you cut a little short section of that, and you can use that as a coupler.
Yeah,
that's exactly right, John. And that's the example of it there. You can see this is 1/4 and this is 3/8. And, one goes inside the other. You can even do it another way. You can actually cut a piece of this off, slit it down. So you take a little bit off, and then you can clamp it with your glue. And that'll do perfectly as well. So there's several ways you can do this. And it's all in your local shops. I mean, if I can do it in Peru, you can do it in the United States, that's for sure. And even Sweden, boss.
Yeah, have a look at the horticultural areas, the places that would have pool supplies, hydroponic supplies for horticultural systems, nurseries.
Even JC, what are those little teeny clamps that you use for car things that have a screw in them, or even the straps?
Shark bites. Shark bites work really good.
Yep. standard screw type pipe clamps will work. Be careful you don't crush your pipe because they're very, very powerful.
Mm-hmm.
In a pinch, you can use zip ties.
Yes.
Get the small zip ties, zip them together as tight as you can get them with your fingers, and then take a pair of needle nose pliers, grab the end of that, and just kind of twist it and get one more click out of it.
Right.
And you can usually seal stuff up pretty good that way.
And then I'll bring up what we're doing in the health beds, or the avatar beds, as some of my South Africa people named them, which is really cool. But it's one tube inside another with two different GANSs. So you've got CO2 and zinc GANS, basically just standing, and I know you've done some of that too, Dave, just standing next to those tubings. I mean, literally, I have my hair practically stand up on my head. I mean, you can feel the fields. You don't even need dowsing rods. And so I wonder how that would work. Jackie, when you use your CO2 and your CH3 GANSs, you're basically mixing them in the tube, correct?
I'm not doing that in the water devices. I'm only really using the CO2 and sometimes CuO for cleanliness, for disinfecting.
Okay.
So yeah, and CuO has the biggest field. So it really improves the size of the plasma field ultimately. So similar to the GANS of GANS. I mean, that's basically, it's GANS made from GANS water.
Right.
Jumping back to a question you asked earlier, Carrie, about putting the plasma fire, for lack of a better term, on your water system. I do basically the same sort of thing with my dog water, because the chlorine content, you were here, you smelled the chlorine.
Right. Yeah.
It is thick. When I fill up my dog bowl for rough, I have a gallon jug of water, clean water. I just take it out of the tap, but it's got, I poured CO2 in the bottom of that jug. So there's always CO2 GANS in the bottom of that jug. And I just put a couple of glugs of that in the dog water.
Nice.
And within 20 or 30 seconds, you don't smell the chlorine anymore.
Nice. I love that. And you're not stirring it, but basically you have, and I've experienced the same thing. I've done a lot of experiments in Florida where there's a lot of parts per million of all different kinds of fluoride, chlorine, whatever else they put in. And I love Tom Salas's, test tube with the nano-coated copper in it that he put in the water. I've done those things, and just putting CO2 GANS in the water overnight, letting it settle. And in the morning, you can just taste that all of your precipitates have fallen to the bottom, and you're dealing with a sweet, nice alkaline water on top. So there's many ways to do it. And that's what I teach in my workshops. You can put bits of nano-coated copper in, or put them in a plastic bag, or put them in a tube, or put the CO2 GANS in, or put the CO2 GANS in a tube. So there's so many ways. And
Vivek came up with a really nice way of doing that. And he took a baby food jar and the lid, cut basically a circle out of the lid. So he just had a ring. You could do it with a mason jar. Get one of the little small mason jars with the 2-part lids.
Right.
He put his GANS in the jar, put a coffee filter over it, and put the lid back on. And that just sits in the bottom of his storage container where he has his drinking water.
Nice.
So the GANS is not actually mixed with the water, but it has an intimate connection.
Exactly. And we've talked about the same thing of even putting a plastic bottle or plastic tube or glass bottle of GANS in a water tank that's feeding a house as well.
Yep.
Dave, what you got there?
Looks like a bong, Dave.
I just wanted to show you this because this is so easy. Yeah, the hydrogen, this is, now, Armin said to me, don't use carbon rods, but John Bliven says, do so. So I think Armin's right in saying that everyone's got their own way of, I think carbon rods are, in Keshe Foundation terms, aren't been accepted just yet, but this is the transfer that goes from one bucket to the next bucket. And we got a nice little hole there. We seal that. Gracias. And then we poke that, and you've got to really seal this. I just wanted to show you that. So you've got to seal that with a bit of glue. I would use probably hot glue on that. And what goes inside here is 0.5 quite tricky. It's the only one that's really tricky. You got to do some hot caustic work, about 60, 70 degrees. And then you put, I'll show you actually, you put little hard pieces of the cut bottle. So there's the hard bit there, and there's the hard bit there. In fact, it's so hard that I can't even cut that. I'll have to do it with a hacksaw. But you put little pieces of that inside your caustic work. And then this is the bleed pipe. And literally you're making hydrogen gold. It goes the gold color, and you put that in a saltwater mix below the wall line, and there's transfer. And you're literally making, if I remember right, I'll have to check it up. I think we're making CO2, and you're blending this. This goes inside the CO2. And then if you go to, it's a similar process, but there's no transfer. The transfer goes into the bottle. You get a little bottle of, you make either.
So you're basically siphoning gas off of that, right, Dave, into the salt water, and then it's precipitating GANS out of the salt water at that point.
If you think of it very, very simply, what with the is that tritium? Yeah, that's tritium. This is tritium. This is CH3. This is just your bog standard CH3, and then you make CO2, and this is how simple it is. You float that inside it, and that becomes your tritium. Okay, so and that's a thick paste mix there of CH3 made with nano-coated material plus the galvanized mesh, the quite sturdy one. And I can make tons of that. I literally can make tons of it. It's so easy. And
wow, I cannot wait to come to Peru and hang out with you.
Well, just over there, where the wood is, that's going to be the new GANS station. So we're going to have 3 GANS stations here. And therefore, we can dedicate one for the new GANSes, and then dedicate one for the old GANSes, etc., etc. So it's going to be pretty well organized here. And we've got a beautiful tiled workshop that is in there, where you see the sunlight coming through, and we're changing the doors there. So we're going to have a pretty good setup here. Now, if we're going to be manufacturing these new PPUs, we think we're going to go back to the old office, which is bigger than here, except the garden. And I think Hector, our director, and Jensen can mass produce these machines once we've got them working here when Armin's here, because he's bringing working units. And we do believe that the secret is in these 3 GANS that we've got behind us. They're being very, very, keeping everything close to the chest at the moment. And we do believe that Mr. Keshe has elevated us to number 4 in manufacturers, because the way he said it in his last workshop, and speaking to Armin yesterday, it looks like we're next. We've certainly been told that. So, and Armin said to me, what's coming here is big, but it has to be well organized. So that's why he's taking his time to get here. I fully understand him, but he's going to make sure that we know how to make this stuff blindfolded, and that's one of his missions.
Nice.
So, Carrie, it's pretty good news for us here, and we're going to be big, quick. We're ready, and we've got a big team here now. We're stretched up to 50 people now.
Exciting.
Last time Armin came here was November, and it was 23, I think. So we've nearly doubled in size, ready for the big day when we have the working machine in the workshop right next to us here. So,
I have a question for you, Dave. Dave?
Okay, boss.
Have you done all the 3 new kind of GANS, like deuterium, tritium, and hydrogen? Did you even do the hydrogen GANS? Yeah?
Boss, you'll have to understand that I've got some heavy building work going on here, and I don't want to put that into any of those GANS. You know, you got people bashing away at tiles, welders going on. I've got the doors getting changed. I've got the steps built. I've got the garden going on. That's energy in itself. And okay, it's good because it's the new Keshe posh offices, and they're really nice offices here. But that is an energy that I don't want to get into these new GANS. So I'm going to wait until about Wednesday, I think, and then I'm going to connect all those up. The problem also is, I don't know if you can see, but the machine that we've got for, can you see the machine over there, which is grey and by the deuterium GANS? We need 3 of those because you need to put power on all of these devices, and we've only got 1.
Thrill cam with Dave.
Pardon?
Thrill cam with Dave.
And well, so we need to buy 2 more, so we need a bit more funds coming in. So these people who are coming here, that they're keeping this place in cash flow. And then we've got the selling of the machines, and I think they'll sell themselves. You know, Peru doesn't take a lot of electricity in each of these houses, so I don't know how far that energy, 40 kilowatts, goes for the PPG, but I can imagine lighting up 100 houses here with that.
Wow.
Mm-hmm.
Exciting.
Jackie, I have a question for you too. Jackie?
Hi, boss.
Hi. What about your super GANs? Have you used them in any energy device or for health or anything?
I really wanted to check with the GDV camera. I'm trying to get this camera. There's none in the US right now. I'm thinking of just ordering one from Europe. I've been using it in plasmatized water. I have a couple of people that have tried it, and it does create a cleansing effect.
Yeah,
So
we went through a detox.
A detox, yeah. I was trying to look for the word detox. So it does put you into a state of detox, which is kind of cool. And then after, when that calms down, everything's fine. But yeah,
We're gonna put it in a car unit.
yeah, we're gonna put it in a car unit.
Actually, we're gonna use a new one, Tritium.
Okay, the duodenum, the
Deuterium.
deuterium. You got me going. Yeah. Yeah, so anyway, yeah, but we are going to be testing out some things, right? I'm looking at understanding that these are all frequencies. Generally what happens is you need a carrier wave. So I was looking for some long wave that can actually carry the shorter waves. Deuterium has a very short wave. So when I look at CUO, I'm now able to stretch it 5.2 miles. I think that's far enough for any tests that I want to do. So that they're all kind of a smaller, more dense field. So yeah, I wanted a carrier field. So that was my plan. We'll see if it works or pans out.
Okay,
Dave, back to your little pop bottle device. For the listeners, in lieu of the carbon rod, what would you use?
How about a nano-coated copper rod?
Yeah, that's the only difference. If you want to stick to the Keshe traditional standard, is just go for the standard nano coating. You could do a health cannon, you could do a spiral, you could use flat plate. But I would say that it's nice and convenient to have a carbon tube because they insert so nice, and if they want it hermetically sealed, then I actually think this is the best method. You can't tell me that that's not carbon. There's no one in Keshe can tell me that that's not carbon, because that's a carbon rod. And, you know, therefore I know what I'm getting if I'm putting carbon in there.
Some of us have, yeah, I love working with the carbon rods.
This is nano-coated copper pipe.
That's nice, Jackie.
Yeah, it was, yeah. So,
Oh dear, she's breaking up pretty bad, isn't she?
Yeah, I will say, you know, like,
the other thing is that
Breaking up pretty bad, Jackie.
Jackie, if you can hear us, we can't hear you.
okay, you guys were breaking up as well.
You too.
Can you hear
Go ahead, start again. Give us.
Okay, so yeah, John Bliven said to use the larger bottles, not the small bottle. It looks like a smaller bottle, but he said to use the large bottle. When you pour in the hot caustic, it's going to shrink up. You don't want it to shrink up too much. So
yeah, so he said use about, I don't know, 60 degrees hot water. Don't go to the 100, because that'll just crush the whole thing. And yeah, I'll be trying that shortly, connecting all the dots and making these 3 over the next month, so that we're ready for Armin when he gets here. That he doesn't need to spend that time. We can teach all the visitors that are coming, that have registered with the Keshe Foundation Peru, and we can teach them that, and they can see it. I mean, all you have to do is walk in here and then just look with your hands, and you'll be able to just go away and make it. In fact, when John Bliven told me, I just kept on running out into the workshop, pulling out something that he mentioned, and I had every single thing here. So you will have every single thing in your garage too. You know, it's all there, ready to go. So you don't have to go out and buy anything. You've got it all.
Exciting. Well, anything else anybody wants to jump in with? Go ahead, Dave.
I just wanted to show you this because I've never had a chance to put this close up, but have a look at my voltage and amp control unit.
I love those. I had somebody using one in South Africa, and it was a great boon to GANS making, because you can really regulate the amount of amps and volts coming through, right?
Can you read what type of model it is? Is that clear? I'm not sure.
No, it's not clear, but there's a bunch of those out there. And all you need to make certain of is that it's a voltage and current controlled unit. Because you can get a power supply that just controls the voltage. The current is, you'll have to actually do the math and set up resistance to get your current limited. But these ones, the type of unit that Dave has there, you could actually dial the maximum current. So if you could even have a short circuit but only pass 0.02 amps through it. And that's the secret with the power supplies, is you have to have that current limiting ability.
That is
really... in Sweden? Sorry, Carrie.
Yeah, I have one. Yeah, sure.
Oh, excellent. Right, okay. And you, Jackie, you got one?
Yeah. Yes, we have one. Yes.
Oh,
I don't.
Well,
and I loved when I asked Mr. Keshe those questions, and he said, you know, if you want to slow it down, just put a capacitor in between the wires of some sort. And he gave me a listing of a bunch of different things. So I've been in these simpler countries where in some places you just don't have access to everything. So there's a lot of ways to do it, but having one of those devices, it sure makes it, it's wonderful.
Yeah,
Carrie,
and
Carrie, are you sure he said capacitor? That sounds strange to me.
Well,
because you can use a resistor, of course, but
Resistors.
maybe it's a resistor. You're more technical than I am.
think so.
Resistors.
Thank you, boss. Yeah.
And those power supply units are not that expensive. You can usually get a reasonably decent single output for somewhere around $50 to $60 US.
Nice. And what are they called again, JC?
It's a current limiting variable power supply.
Current limiting variable power supply.
And ours cost here in Peru, I bought it with Noe down in Lima, and ours was just less than $60. So, you know,
Nice.
we're paying pretty nice price too. So
Nice.
Yep.
Yep.
Ali,
We need 3 more. We need if we're gonna be mass producing here, which we are. So we're gonna need 3 more of those. So, you know, if anyone's wondering where the money's going, that's where it's going. It's on urgent things like that, you know.
Great. That's awesome, Dave.
Yeah, if you're ordering them, excuse me, if you're ordering them off the net, AliExpress.com has dozens and dozens of these units. There's a whole number of them you can choose from. You can get them from Amazon, but they're a little pricey. If you have an electronics component store, they will have them as well, because they're a very common benchtop power supply. But make sure when you're asking for the unit that it's current limiting. You can adjust the current.
Very good to have those technical details. Jackie, do you have any more on your frequency evaluations or?
That's it.
And
yeah,
so far you've been doing your tests with the basic GANSs, CO2, zinc,
yes,
CH3, and CuO2, and you haven't moved on to the hydrogen, tritium, deuterium yet, correct?
I've made deuterium, and John Paul, yesterday I have not had a chance to check them both yet. But so yeah, we're starting that venture right now, and we'll see. And also, just to clarify, we don't know what the different size fields actually do, if they actually have a great effect on this. The theory is, though, that we do want to create a healthful environment, and the idea is to stretch the plasma field as far as we can. And this was a really easy way of doing it. 5.2 miles is kind of nice. It would be very easy now to take that up and just repeat. Mm-hmm.
Right. So I have a question. You're kind of the queen of car units. I mean, you guys have produced a lot of car units out there. I've been there working with you on car units. Have you used some of your kind of super GANs, we'll call it, outside of these more advanced GANs, just of your basics? The ones that you've potentized more powerfully, have you used those in car units yet and see any difference?
Here's the interesting thing that I'm kind of feeling, but I really want to double check with the camera. What I've noticed in using the rods, for instance, let's say the size of the field is 100 feet. What I'm feeling is that the maximum power of that field does not occur at the beginning, like where the object exists. It's actually occurring maybe halfway through the field. So it's almost like a toroid. So I really want to look at the camera. So I'm not sure that you really want that much larger field if you're dealing with something with a car. That's where the hydrogen GANs will come in. So, but what I'm building these for is as a carrier GANs. In other words, let's say if you're going to use something like a spaceship and you want to go off far, obviously you need a field that is ahead of you. So this will create a field that is ahead of the object, not where the object exists. And it also raises a question as to, if we're going to create these fields and if the strength of the field is actually away from the object, that maybe we need to create these fields for our neighbor. Maybe that's where the field has the best benefit. Like, my field created here. Interesting observation, because I came to this observation, and then the other day, an article, they're working on a plasma car. It's got nothing to do with Keshe technology, but one of the things that they had noticed is the power of the plasma field they could not replicate in the lab. They couldn't test it in the lab. They can only test it outside, which kind of makes sense to what I was seeing. I'm seeing it not close to the object. I'm seeing it away from the object.
Very interesting.
A lot more things to look at.
Yeah, that's awesome. Very interesting. Okay, I think we're kind of maybe on a time frame here. We should bring this segment to a close. Anybody have anything else they'd like to jump in with before we close?
Yes, I have a general car unit question because I've been struggling with my car units and not too much success really. But Keshe mentioned some time ago that when you do a car unit, you should fire nano coat the stuff. Are you doing that or?
No, I'm using John Bliven's method of nano coating. I would like to try fire coating. I know JC had a good video up on how to do that. I've kind of been caught up in my own, crazy little world here. And there's a few things I need to go back and check. What I'm trying to do right now is do various tests and then get a feel for what I think is the best one. Nano coating is one of those ones I really want to look at next.
Okay, as far as the fire coating goes, I don't know how well this is going to show up on camera. It may still look black, but this is a health pen that I fire coated some time ago. Sorry about the dirty hands. I've been playing with the dog.
It's okay. Looks good, JC.
Oh, that's not the nano coating.
when I there we go. That's better. When I first did it, it came out really nice and black. Beautiful, looked great. And I just let it sit. And this is about a month later, and it's starting to turn coppery again. So this was coated, went through 2 processes. So with the fire coating, it does change over time. The caustic coating does change over time as well, but I've noticed it grows darker over time with the caustic. With the fire coating, it grows lighter over time. So be aware of that when you do this. I'm not certain if that affects the unit significantly or if it's simply I didn't run it through the processes enough. So if you do a fire coating and you go back 2 months later and you look at your copper and it's copper colored again, be aware that that is happening. I've done this several times. I've got several things that I've fire coated, and every single one of them is doing exactly the same thing.
And to add to that, John, when Brett Sutherland was here and he built the health unit upstairs, obviously we can see the fire coat, the nano coating with the hot caustic method. But he also used the third stage. He put into baggies in the sun and left them there for a couple of weeks, and it's going black. And I have to spray that machine to get it to work by the back caps that he made, 10 back caps, and I have to spray them. So I see those things every day, and they are, how old's that unit now? Can you remember? It's got to be 6 months old.
Pretty close to that, yeah.
Yeah, and they're as black as the back of the fire grate.
And he did it by what method, Dave?
So you do your irrigated caustic method. So you bury everything in hot water and caustic.
Yep.
Round 1, round 2, hot caustic steam.
Right.
And then he takes it out, and then the next one is 2 weeks of glorious sunshine that we have here all the time. And
boy, I'll tell you, I've been nano coating like that for a year, and it makes beautiful, beautiful nano coating that seems to last. And I think the sun, maybe, we talk about bringing in the natural elements, and I think doing it in the sun, doing that steam nano coating or the cold caustic nano coating in the sun brings in that natural element that maybe we're going after with the fire. You know, I think there's sort of that bringing in, I don't know. Yeah.
Well, it's not only that. It's not only that bringing in the natural elements using the sun, but it's also the time. Take your time with your nano coating. Let it go 2-3 weeks.
Yes.
That's where you get a very, very tough, very robust coating.
You do. I see that over and over.
Now, here's the final thing for you. Mr. Keshe was talking yesterday about how to clean the residue off from the caustic method, because we know it's toxic.
Right.
Now, when you do come to Peru and you walk through this door, the first thing you'll be confronted with is 2 volunteers that I've got here, one from Australia, and there are a couple, one from Australia and one from Spain, very lovely people. And they have instilled that we clean the whole floor, your computer, and everything with lemon, lime, and baking soda. We even wash the dishes with it. We even wash our bodies with it. We've taken every single chemical out of here, and that's the first thing you get confronted with. We think that is the way forward for the cleaning the caustic residues off your nanocoating. But we're going one further, because this lady here said to me that lemon and lime leave a residue when you clean the floor. You can see it. So go to apple vinegar. Don't go to white vinegar, because that's not fermented, but apple vinegar is fermented. That will take away any residue that you've got and not leave one itself. So there you go.
Consider the point, Dave, that you're using a highly caustic environment to generate the nano coating. If you put that nano coating in an acidic environment, there's a very good chance it's going to reverse your nano coating process. We've seen that with the silicone, remember?
Yeah.
With the issues we had with your car units using silicone, where initially they work great, over time they just slowly fail and eventually don't work at all. Do a test before you actually do something important with this. Take some nano-coated materials, put it in some ACV, and let it sit and see what happens to the nano coating. I have a strong feeling it's going to reverse the process. It's going to turn that nano coating back into its elemental copper.
Very interesting point. And we definitely do need to test.
Just very quickly.
Okay.
Very quickly. Okay, so This is what's going to be available with John Bliven. This is a little motor that will spin. I haven't actually set it up yet, but I have connected to my power. But just to show you, these are going to be available at the USA store, maybe later today. So actually, he has a really nice board and a really nice setup. This is just a sample that he gave to me. So anyway, I'm very excited. We're going to be playing with this, and when you use your new GANSs in here, it's going to create a really nice film.
And so and you, Jackie, are a distributor. They could find out about getting these through you, or would they just check with Keshe?
Yeah, they can go straight. Yeah, either one, but check it out. So they'll be available in USA for people that are interested in making their reactors. I've been dying to play with them, so I'm very excited.
Live to play with them.
Do you know what speed it is, Jackie? Do you know what speed?
It has a little controller. He said, be careful, don't take it up too high. He knows what I'm like. I'll be going 5.2 miles or whatever, 10,000 RPMs or whatever. Yeah, he did show us one that kind of did explode on him. So you do want to be careful. I think he has them spinning around 2,000. He says they don't have to be much more than that. But, they did have an accident, so watch out.
We had similar happen here, and I was picking pieces of plastic out of my chest for a couple of days, So, and I think Juan took it up to 16,000 RPM, so I think he was a little bit too brazen with his efforts there, but never mind.
Yeah,
If
you're going to go that fast, you need polycarbonate, and it has to be a very thick wall and small. The smaller the ball, the faster you can turn it before it's going to fail.
Yeah.
If you have a 4 or a 6 inch ball and you're turning it at 5,000 RPM, the speed of the surface, okay, because you got to think of the surface speed. Roughly, you multiply that by the diameter by 4, which gives you the distance around, and you multiply that by your speed. So at 5,000 RPM, that's roughly what's 5,000 times 12, 60,000 feet a minute.
Yeah,
right. That's pretty fast. And the centrifugal force pulling out on that plastic, the plastic will fail. So if you're going to go really high speed. If you're going to go really high speed, use very small balls, like 1 centimeter, ½ inch or less.
Yeah.
And then you can turn.
The other thing is, don't forget you nano coat lightly on the inside of the ball, so that will weaken it as well. So take that into consideration. So in terms of nano coating, he said, what do I do with my ball now? It's see-through. So you just spray a little bit, leave it in there for 10 minutes, wash it out. That's it. Don't, be leaving it in there for a long time, because it will just eat away at the inside.
Yeah. And to go back to what Dave was talking about cleaning your nano coating, I simply rinse mine in warm water. And I've got a system. It's one of the kits from Arizona that I was working on putting together for doing videos and stuff, but I ran out of resources. I don't have the resources to continue. But it's been sitting on my counter now for probably 2 months. And that, once it was done nano coating, it took 3 weeks to nano coat. And I just rinsed all the parts off with warm water, set them on a paper towel and let them dry. And there's no residue on those. They're black. Like I mentioned before, they look like a hole in reality. They are so black.
Wow.
John Bliven says the same thing. So just watch.
I'd just like to interject there, because John probably has answered this himself unwittingly. I think if you put water, now you said you clean yours with warm water, and you put an alkaline environment, so you put just baking soda, get the lemon out of there, and just use your baking soda, that's going to take that residue right off, and you're not creating an acidic environment, so you're not doing any damage to your nanocoating. So maybe just baking soda, John.
Well, the caustic has such an affinity for water, excuse me, and when it comes out of the steam, there's such a small amount on there. If you just take if you just take it right out of the steam, set it down, let it dry, you will get a little bit of a crust build up on there. But it has such an affinity for water. Like 30 seconds under warm water, just rinse it off. I'm not seeing any residue whatsoever after that.
Exactly. Yeah,
And I know that's safe. I know it's safe. If you don't have really clean water, like I just use tap water for that. If you don't have really clean tap water, you can take distilled water, warm it up, and dunk your pieces a few times. And then rinse them. And after that, you could rinse them in just plain cold water at that point, because the concentration of caustic left, whatever's left in that water is going to be small. It's not going to make a difference.
You guys, let's call this segment to a close, just for timing. I kind of need to end it. But obviously, I know we can continue with plenty of wonderful conversations here. We've got so much knowledge that's being put into practice among us. It just warms my heart and my soul, and I'm glad we can share this with others who are out there doing their own experimenting and learning as we kind of move into this field of new science. Anybody have a word in closing? We'll see you all soon.
See you all soon.
Yeah. Yeah. Thanks.
Thank you, Carrie.
So much love and many blessings, and we will catch up soon. Ciao.
All right, bye.
Bye bye.